Hey everyone, welcome to another video of me, Pedro Marques, founder of Nautical. Today I want to talk about the expectations I had when I decided to become an MLOps engineer, some of the things I realized, and the reality of the matter of being an MLOps engineer. So we're going to cover a few concepts of the things I learned versus the things I thought I would experience, and so far as the work I'd be doing as an MLOps engineer. We'll also cover some of the tools I've been using and other lessons I've learned along the way. So let's kind of go over this, cover a few points, and hopefully some of you who are becoming an MLOps engineer understand what your role is and what you'd be doing. Alright, so my first realization when I became an MLOps engineer was that I assumed you'd need to be proficient in data science to get a job. You know about modeling, data cleaning, model evaluation, all that stuff. And I assumed the data science part was the most critical and you could learn the rest as you go. What I found out was that MLOps requires expertise in 4 fields, each demanding years of professional experience to master: data science, software engineering, data engineering, and DevOps. For example, at my first job, I built a feature engineering pipeline, built ML models, and experimented with new features and models to improve the performance. These are the tasks that you expect data science to do. However, I also needed to write feature engineering pipeline in Spark and create orchestration pipelines to automate the ML model deployment processes in Airflow, like you'd expect the engineer to do. Of course, there are some differences between an MLOps orchestration and a data engineering orchestrations. MLOps orchestrations, based on my experience, automate ML processes, most commonly feature engineering pipelines, while the data engineering orchestrates data pipelines that feed into your feature engineering pipeline, as well as many other pipelines across the company. Next, I found myself setting up an MLflow server in Docker and Helm chart, and building CI/CD pipelines with branching strategies, which is typically a DevOps task. At my last job, I was asked to define ML best practices across 3 business verticals, where I had to define the foundation to scale to more models. This meant building code with clean code, best practices, versioning, test-driven development, and of course, deployment. These, again, are typical software engineering tasks. So you already see where I'm going. And honestly, this makes a lot of sense that an MLOps engineer needs to know all these 4 fields when you think about it. For a second, you need data science because it's important to guarantee the model fitness, integrity, and sustainability throughout its operational life cycle. DevOps, like the name says, is important because MLOps is fundamentally defined as the discipline that connects code with operations, effectively bridging the gap between DevOps and the ML world. Software engineering is important because it provides the efficiency, clean code, stability, and scale necessary to deploy and manage the models. Data engineering is important because you must architect and implement data preparation and feature pipelines in Spark, dbt, or Flink necessary to guarantee the model reproducibility and continuous training. Again, this might change depending on the company. For example, if you work for smaller teams, you'd probably do these things and even more. But for larger ML teams, you'd probably not do any of the modeling experiments because you have data science to do them. So I think this was something I learned very quickly as far as reality versus expectation. And so for my next expectation, I assume that the model versioning is sufficient to safe upgrade or roll back. This is kind of alright. You'll version a lot of models, but the other thing no one told me is that a lot of your work as an MLOps engineers involve versioning the data the model ingests too. Storing the model somewhere is usually a no-brainer because you want to store the model somewhere to avoid having to retrain it over and over again every time you want to use it. If the model takes 5 hours to train, by storing the model, you just save 5 hours. Versioning is more related to governance so that you are able to roll back to a previous version easily in case there are issues and to know who deployed what. You'll often use some model registry tool for that, such as MLflow, Kubeflow, Vertex AI model registry, and many more industry ones that you can use. You start valuing versioning data when you have a model with a certain performance and you want to compare it with a new one. To make the comparison fair, you want to use the same exact training data to compare the models. The issue here is that if you didn't version the data, you might use a different set of data than when you trained the original model. So the comparison will be flawed since their foundation. To solve the issue, you'll often use data versioning tools such as DVC or LakeFS. If you're joining a company taking their first step in ML, you're likely the one building all this infrastructure that I just talked about. If the company is already quite ML mature, you'll end up just maintaining and improving the ML platform someone else built for you. And so for my next expectation, I don't think it was so much an expectation as it was just a reality check. When it comes down to it, MLOps engineers get very little fanfare. You rarely see articles talking about the sexiest job of the 21st century being an MLOps engineer, or anything similar to that for a matter of fact. Instead, you'll often find a lot of the fanfare still goes to the data scientist area because their work is more tangible and more noticeable by executives and by management. They are often the ones creating the machine learning models out of the infrastructure that you build. So at the end of the day, regardless of what you do, it's kind of behind the scenes. Our work is the core layer that no one ever sees. We're just this middleman between data engineers and data scientists and software engineers. If you're expecting a lot of people to be talking about your role or talking about the work you've done, it's going to be a little bit more challenging just because you tend to be behind the scenes. It's just the nature of the role, nothing wrong with it. Now for my final expectations, I only assumed that when I became an MLOps engineer, experiment tracking was purely a data scientist's job, something they kept in some CSV file or Excel sheet, and that I would never need to worry about it. I thought that as an MLOps engineer, the most important part was the data and the final model, not the different experiments that the data scientists ran to get there. But oddly enough, I discovered when a data scientist leaves the company, if their experiments aren't stored in a centralized place, they leave with them. Without that experiment tracking information, the new data scientist has to repeat the same hundreds of experiments the other one already knew wouldn't work. And if the original data scientist has been working on a project for long enough, even they might forget which experiments they've already tried. So it's a huge time waster for everyone. Having all that information in one centralized place is a huge time saver for everyone. Now here's a more advanced topic. Let's say you have an experiment tracking tool. Great. Even then, data scientists often end up pulling the information into a notebook just to compare experiments, because the tools itself don't make those comparisons easy. If that's your case, consider using tools such as MLflow or any other that offers out-of-the-box charts you can spin with simple configurations. And with that, I really appreciate everyone's support. If you enjoyed this video, consider clicking the like button. It helps me understand what videos are great and also probably helps the YouTube algorithm understand what videos to show other people like yourself. Let me know if you have any expectations versus reality on your job in the comments. Other than that, I'll see you in the next time. Thank you and goodbye.